In this video, we're going to be looking at trigonometric integrals. Now, this is a very long section. I have like 15 problems in this set of notes, so I may end up actually having to do 4 videos for this section. So we're going to start with integrating products of powers of sine and cosine. And this is the video that's going to take the longest amount of time. So we're going to kind of watch the time and see how long it's actually taking me to do this. And again, I might break it into 2 different videos. So in the textbook, you've got this set of rules, the problem-solving strategy, which if you read it, try to make some sense out of it, you may or may not. So what I'm going to try to do in this video is to verbally go through and give you the technique for what you want to be looking for. It's really not that complicated, but there's a lot of different options that you have. So the best way to do it is to just get in and start with the first problem. But again, you should go over these problem-solving strategies. So the first one, this one is actually a very straightforward problem. So you're going to have an integral with a mixture of cosine and sine functions of different powers. So the first thing that you want to look for in any of these is, do you have a single power of either sine or cosine? In this case, you have sine to the first power. You have cosine to the third power, but sine is just to the first power. So if you have cosine or sine to the first power, and the other trigonometric function is raised to some other power, then you can just use U substitution. So in this particular case, we're simply letting U be equal to the cosine of x. So what we have is a U cubed cosine x to the third power. Okay, because remember that cosine cubed x is really the same thing as cosine x cubed. And so the derivative of cosine is negative sine of x dx. And so solving that for dx, we have du over negative sine of x. Substituting everything in, sines cancel out, that negative comes out in front. And so we just have a straightforward U substitution problem. Substituting back in what U is equal to, we have this. So again, the strategy here is, if you have sine or cosine, one of the functions is raised to a power other than 1, and the other power is just a single power, then you can use U substitution. But that is not always going to be the case. So in example number 2, we see that cosine is raised to the second power, sine is raised to the third power. And that makes it much more complicated. So what we want to be looking for is look for an odd power of either sine or cosine, okay? An odd power of sine or cosine. In this particular case, we have an odd power of sine, sine to the third. So what we're going to do is we are going to factor that odd power of sine into sine squared times sine. Now, we're going to factor out a single power of sine. Okay, factor out a single power of sine. That means we have sine squared times sine. Then we are going to use a trig identity. This section involves many trig identities. One trig identity that you're going to be using a lot is this, sine squared equals 1 minus cosine squared. And that comes from sine squared x plus cosine squared x equals 1, which is a version of the Pythagorean theorem. That's one of the Pythagorean identities in trigonometry. So we're just solving this for sine of x is equal to 1 minus cosine of x, squared x. So when you have a sine or a cosine raised to the second power, what we want to do is substitute this in for it, 1 minus cosine squared. So what we're doing then is we are getting rid of all of the sines except for that one that we factored out. So if we go over here, we have this integral is being rewritten like this. Cosine squared is staying the same. times the sine squared times the sine that we factored out. Then we substituted in the 1 minus cosine squared. So now what I'm going to do is I'm going to multiply these two together to get cosine squared times 1 is cosine squared. Cosine squared times cosine squared is cosine to the fourth. I don't know if you can read that. I actually wrote the wrong number in there. So we have cosine squared x minus cosine to the fourth x, all times sine of x. Multiplying through the sine of x, and then breaking them up into two separate integrals. You don't need to break these into two separate integrals. That's the way that I like to do it when I'm writing it out. Mentally, you are probably breaking it into two separate integrals, but whether you actually write it that way on paper is up to you. I like to do that. So cosine squared times sine of x gives us this integral, minus cosine to the fourth times the sine of x gives us this integral. So now we're back to a problem like number 1. Remember, problem number 1, we had a single power of sine or cosine, and we use U substitution. That's what we're aiming for here. All right, that's the whole gist of what we're doing here. We are aiming to get a single power of sine or cosine, where we can now use U substitution. So again, using U substitution, U is equal to the cosine of x, du is negative sine of x dx, so dx is equal to du over negative sine. Doing the U substitution here, finding the antiderivatives, and then integrating, we get this for our answer. So, to recap, when you have a mixture of sines and cosines raised to powers greater than 1, you want to look for either a cosine or a sine that is an odd power. Factor out a single value of the sine or cosine, and then we're going to be breaking it up into a problem where we can use U substitution. All right, the next one, I'm looking for an odd power of sine or cosine. I don't have one. In fact, all I have is just a single function, sine, and it's raised to an even power. So when you have sine or cosine raised to an even power, you have to go to a different trig identity, as we have over here. So you will remember one of your trig identities. I believe they're the double angle identities. And so you're going to you have the sine squared of x is equal to 1/2 minus 1/2 cosine of 2x. And then you have the cosine squared x is equal to 1/2 plus 1/2 cosine 2x. The only difference between these is the plus or minus sign. And so these are some more identities that you probably want to get to be familiar with. So whenever you have an even power of sine or cosine, this is what you're going to have to do. So we simply substitute that in here. I then break it into two integrals. The integral of 1/2 dx minus the integral of 1/2 cosine 2x dx. Bring the 1/2s out in front. And so the antiderivative of dx is simply x times 1/2. And so then cosine of 2x, this is the antiderivative of cosine. This is basically a U substitution problem, but in this case, U is equal to 2x. So we've done lots of these before. U is equal to 2x. So the antiderivative of cosine is sine. And so you have to, put in that 1/2. So it's actually the 1/2 times the 1/2 gives us the 1/4. So we found antiderivatives of cosine of double angles before. If I need to, I can do a little refresher on that. So that's that. That was easy. That's your answer. Number 3. Okay. So we are back to a mixture of sines and cosines. In this case, cosine is even, sine is odd. So remember, we are looking for an odd power of sine or cosine. In both these problems, it just happens to have been sine. If it was cosine, we'd be doing the exact same thing, except we'd be factoring out a power of cosine rather than sine. So we take sine to the 5th, and we break it into sine to the 4th times sine. And so we rewrite our integral like this. Now, sine to the 4th. In the last problem that we did, 2 problems ago, we had a sine squared, and we substituted in the 1 minus cosine squared x, but we don't have a sine squared. We have sine to the 4th. Oh, that makes it just all the uglier. So we take the sine to the 4th, and we break it into sine squared times sine squared. Then we take each one of those sine squareds, and we rewrite it as 1 minus cosine squared times 1 minus cosine squared. Multiplying those together, we end up with 1 minus 2 cosine squared plus cosine to the 4th x. And notice the cosine to the 8th just keeps coming down. The sine x dx just keeps coming down. And now, multiply these together to get this. And all of that is times sine of x dx. And so now I'm going to multiply each one of these terms in here times sine of x dx, and then put them in their own integral. So cosine to the 8th times sine gives me this, minus 2 cosine 10th times sine gives me this integral, and then cosine to the 12th times sine gives me this integral. Once we get to that point, it's U substitution again. All right, we're always going to finish these off with U substitution, where U is cosine of x, du is negative sine x dx, so dx is equal to du divided by negative sine of x. I'm not showing all the U substitution at this point in time. You should be able to do that. So knowing that it's U substitution, we come up with our final answer being this. Okay. Let's take a look. Oh, now we have a sine to the 4th. So 2 problems ago, we had a sine squared. So what are we going to do with a sine to the 4th? Well, we're going to do something similar that we did in the last problem. Remember when we had a sine to the 4th? We broke it into sine squared times sine squared, right? And we know that, and in this case, we have, there's a couple different ways that you could do this. But in this particular case, it's going to be easier to then use this identity. Sine squared x is equal to 1/2 minus 1/2 cosine of 2x. And so we're going to have that twice. Okay. We take sine to the 4th, break it into sine squared, sine squared. We have cosine 2x. And so now you're going to multiply those together to get this, right? You have the 1/2 times the 1/2 is 1/4. And the inside function is the outside. You're basically foiling it, and you get that. Then, let's see. Okay, so now we have another problem, and that would be right here. We still have a cosine squared. So guess what we're going to do with the cosine squared of 2x? We're going to go to our formula again. But now, in this case, we have cosine squared of 2x, not cosine squared of x. When you have a single x here, you end up with a 2x over here. So we have a 2x here. We end up with a 4x down here. It's a double angle. You have to double that angle. So we substitute in, this becomes this. So everything else just comes on down. And remember, be careful. You are multiplying all of this. You're multiplying the cosine squared. When you substitute that in there, you're multiplying that all by 1/4. So don't forget to multiply by that 1/4. And so when you do all of that, you end up with this. And so now we can integrate each one of these terms using U substitution. Here, your U is equal to 2x. du is equal to 2 dx. So dx is equal to du divided by 2. So you just end up with a 1/2 factor in there. So 1/4 and 1/8 combine to be 3/8. This just comes down to here. This just comes down to here. So that's simplified. And then integrating, 3/8 becomes 3/8x. The antiderivative cosine is sine of 2x. And then you have the 1/2 times the 1/2 to give you the 1/4. Cosine, again, becomes sine. And the 1/2 times the 1/8 to give you the 1/4. Yes, 1/4 times 1/8 to give you the 1/32. And so there's your final answer. Well, that's 16 minutes. I usually like to finish it off at this time, but I'm just going to plug on through. This will be a little bit longer video. In this one, we have an odd power of cosine and an odd power of sine. So remember, we're looking for an odd power of sine or cosine. Pick either one, doesn't really matter. So what I did in this particular case was I took the odd power of cosine and I broke that down into cosine to the 4th cosine. So remember, what we're doing was we're factoring out a single power of cosine. And so we rewrite the original problem so that it looks like this. Now, cosine to the 4th x, I did over here, doing some of this on the side. Cosine to the 4th is cosine squared times cosine squared. And so remember that cosine squared x, one of the identities is 1 minus sine squared x. That's the Pythagorean identity. But since this is to the 4th power, that's the same as squaring that. We're going to square this. And so when we square that, we end up with this. You're essentially multiplying it by itself. I then substituted that in over here. All times sine to the 9th times cosine. So multiplying it through by sine to the 9th, we end up with this. Sine to the 9th times 1 is sine to the 9th. Sine to the 9th times a negative 2 sine squared is a negative 2 sine to the 11th. And sine to the 9th times negative sine to the 4th is it's positive sine to the 13. All right, so now I'm going to multiply everything through by cosine and break it into their own integrals. And so that's what I have here. All I'm doing is really attaching the cosine at the end of each one of these so that I can do U substitution. And so in this particular case, U is the sine of x. Du, the derivative of sine, is cosine. So dx is du over cosine of x. Using U substitution, we end up with our final answer, which is right there. And I believe this is the last one. Yep. At least for this video. Okay, I haven't used violet. So, in this case, we have even powers of sine and cosine. So we've looked at problems where we had at least one of the functions had an odd power, and we factor out a single factor of sine or cosine from that. We've looked at problems where we had just sine or just cosine to an even power. So now finally we're looking at problems where we have sine and cosine both to even power. So this just involves a lot of the use of the trig identities. So in this particular case, we're using the trig identities where the sine squared of x is equal to 1/2 minus 1/2 cosine of 2x. And cosine squared of x is 1/2 plus 1/2 cosine of 2x. Then multiply those together. When you multiply those together, now here's the nice thing about multiplying these together. They are conjugates of each other. So remember, a conjugate is something in the form a plus b times a minus b. And when you multiply conjugates, the middle terms cancel out. You just end up with an a squared minus b squared. And so that's what we get here. So multiply those through, and you get 1/4 minus 1/4 cosine squared of 2x. Then, well, we got to go back and we got to get rid of this cosine squared. So you know what we do? You got it. We use the identity again. But this time we have a double angle, so it becomes to a fourth angle, 4x. So we just substitute that identity in. Basically, anytime you have an even power of cosine or sine, you're going to be substituting one of the identities in. And so now from here, very carefully go through and multiply everything through to get this. And then we can actually find the antiderivative. Now, what I should have done was I should have combined these two terms first, but I didn't. So I just got 1/4 x minus 1/8 x. And then using U substitution here, where u is equal to your 4x. And so du is equal to 4 dx. So dx is du divided by 4. So we have a factor of 1/4. So 1/4 times the 1/8 gives me the 1/32. And then I combine these two. 1/4 is 2/8. 2/8 minus 1/8 is 1/8. Minus 1/32, sine of 4x plus c. And there's my final answer. All right, so this takes some time to just play with. Go through my examples multiple times if you have to. Some of these examples are from the textbook. Some of them are actually from WebAssign. And make sure that you kind of develop a mental strategy for how to go about doing these. All right, see you in the next video.